Angular momentum question 2. A fairground roundabout has a moment of inertia of 6,500 kilogram-meters squared. The motor takes it from rest to its maximum speed of 1.6 radians per second in 12 seconds. Calculate the torque it must produce. Well, to find the torque, we must first find the angular acceleration, which is given by the change in angular velocity divided by the time taken. This is equal to 1.6 radians per second divided by a time of 12 seconds, giving an angular acceleration of 0.13 radians per second squared. Well, moment of inertia is equal to torque divided by angular acceleration. So torque is equal to moment of inertia multiplied by angular acceleration. Putting in the values gives a torque of 870 Newton meters. The same type of motor is also used on a smaller, lighter roundabout with a moment of inertia of 4,000 kilogram-meters squared. What angular velocity will the roundabout have 8 seconds after starting? Well, moment of inertia is equal to torque divided by angular acceleration. So angular acceleration is equal to torque divided by moment of inertia. Putting in the values gives an angular acceleration of 0.22 radians per second squared. We can now use this equation, the final angular velocity equals the initial angular velocity plus the product of angular acceleration and time. Putting in the values gives a final angular velocity of 1.76 radians per second. What angle will the roundabout have turned through during this 8 seconds? Well, now we can use this formula. Putting in the values gives an angle turned through of 7 radians. The ride now continues at this speed with the motor operating at a power of 1 kilowatt. What torque is produced? Well, power is equal to torque times angular velocity. So torque is equal to power over angular velocity. Putting in the values gives a torque of 570 Newton meters.